going to be talking about my ICE presentation. So, who am I? My name is Reyansh. I'm a senior at First High School, and the topic I decided to research is electrical engineering. Specifically, it would be photonic chips. So, I'd like to start off with a nice little quote. Sometimes life is like this tunnel. You can always see the light at the end of the tunnel, but if you keep moving, you come to a better place. That quote's one of the shows I like a lot. And yeah, it's one of the best shows ever. Go watch it.
You need me to spell my name out.
So now let me talk a little bit about what exactly is chip design. So chip design is kind of like designing these unique computer chips that are added up. But chip design is basically a bunch of these like transistors, and they're connected together to form like a delivery system. This delivery system is called the CPU, and there's like a bunch of different delivery systems, like the GPU and other stuff. And then these all handle inputs made by the client and calculate what the computer device is to show on the screen. So these are so basically, yeah, these all have like different purposes, and they just come together to make your computer or phone work. So just imagine like if I click the mouse button, it goes in the computer, and the chip tells the computer what should happen next. And so that's how it works. And chips are what tells the input to become output. So, I would like to talk about the essential components of the chip. So, we're going to start off with transistors. So, transistors are like these tiny electronic switches that control the flow of electricity in a circuit. In computer chips, billions of transistors turn on and off, very quickly to represent ones and zeros. Like you probably heard ones and zeros are the backbones of computers, and that it is true to some degree, which allows computers to process information and programs. So all these like zeros and ones, it just tells like every like little pixel what to light up, what information should go through and what should not go through. And this is like a simple diagram of a transistor. So like these are your logic gates, and yeah. So like here's a gate, right? So fun fact, the first transistor ever made was actually here in Texas at TI's factory. That was in 1950. That's how it was pretty big. That's why it's really big. So that's why you see like in like old images of like huge supercomputers, but they were not actually really powerful compared to today's standards. Like the first computer was like I think the size of a room or something. All right. So now, when you have transistors, you need wires to connect all these transistors together, and so that's what forms like your basic chip. And this chip actually is 50 years old, so it looks really complicated, but somehow it's like super old, like 50 years. It's pretty cool how neat our technology was back then. So, how are these chips exactly made? Now, here's a little image from a movie, Spider-Man, and you can see our boy Spider-Man here is messing around, and he's designing a suit, and what this little device is, now this is like non-fiction, right? So, but like this is supposed to be a fab where they like make these like chips and stuff that goes on this suit to like help him use his superpowers or whatever. So like basically these fabs are kind of what you need right now. Now, in these fabs, what happens to make a chip is called lithography. Okay, we use a process nowadays called extreme ultraviolet lithography. I'll explain that in just a second so you can understand how it works. But basically, after chips are designed by engineers, like you design it on a computer, like in like an app or something, right? Then using lithography, you print the circuits onto these silicon wafers, and these wafers are not like a cookie. We're not talking about that kind of wafer. So basically, it starts off with sand, the process, and from sand we like extract the silicon, and then using the silicon, you make the wafers, and then that becomes the chip. The wafers have like a bunch of little squares in them, right? And so each square is like one chip. So one wafer is like thousands of dollars. So this is a example of silicon looks. So what they do is they have like sand and then like they spin around really fast and it kind of turns into like cylinders of silicon. And then once you have these cylinders of silicon, they chop it up to make those wafers I showed on the screen earlier. So these are kind of how it looks like. So you chop up the cylinders and you get like little thin discs, and that's what you can print the chips onto. So now this is kind of like the most complicated machine created by mankind right now. It's called ASICon, and basically this is the process of how printing onto the wafers kind of works. So they start with a laser. I'm gonna try to explain, but it's kind of complicated, so bear with me. You shoot a laser, and it passes through all these mirrors, and then on the actual chip, it starts etching out the design for the chip, and it's like super precise, like to the picoradians, which is like very very precise. And the reason they use mirrors is to kind of keep it as small, like have the beam of light on the chip as small as possible, because the closer together these transistors are, the more energy efficient they are. So, and that's called UV radiation. I would explain it, but kind of running low on time right now. And those mirrors that bounce off the light, it's actually the smoothest object on Earth. And yeah, it's just used to bounce light very precisely. And yeah, this is kind of an image of how printing looks like. As you can see, the laser is going onto this wafer and it's like etching it the chips out. And you can etch multiple layers of these transistors and stack them on top of each other and connect them through wires. So you don't have to just make huge long chips. You can also like stack them in 2-3 layers up. But usually your transistors will go here, and then wires will connect the transistors through multiple layers. So basically most of your transistors will be on the bottom layer of the chip. There's this popular law called Moore's law. It was I think made by like the founder of Intel or something, or like someone like that. And basically observed that the number of transistors on a chip is going to double roughly every 2 years. So like as the chips get smaller, more and more transistors are added. So we talked about Moore's law a little bit, and people are saying that it's not going to be as applicable today because of how it's harder and harder to get smaller and smaller, because now we're dealing with electrons, and it can leak, like electrons can leak to other, like, because it's so small. Currently TSMC, which is like the leading company, is on their 2 nanometer node, which is like super small. And if you go too small, then it's like really hard to control these atoms. My goal is to research new ways that we can continue Moore's law. And so I delved on photonic chips. I'm going to rush a little bit, but because we're time's almost up. But so yeah, I'm learning about photonic chips, and it can be like super energy efficient and produces like little to no heat and stuff. So that's why it's really good. This is kind of like an example how we currently use photonics and optical fibers, those wires that go across the Atlantic Ocean. I interviewed 2 people. I don't want to talk right now, but yes, they're right there. And no mentor, unfortunately, but I have been researching on my own. And basically, these waveguides are how, because photonics, so in a normal chips, you use electricity. In photonics, we use light to make calculations, like the 1s and 0s. So these waves are like used different color stuff to make different calculations. And I've researched about a company called Light Matter, but I gotta move on. But I'll talk about my final presentation. Are photonics reliable? For now, they are not reliable because currently, like your screens that you see all the information from chips are using electrons. But if you use if you use photonics in the actual chips, then converting electricity to photonics and then photonics back to electricity causes a delay, which currently is slower than just using a normal electronic chip. So right now, photonics are not viable, but like I said, there are companies like White Matter that are trying to fix that. And so, debate between quantum versus photonics. Quantum computing is more of like complex problems, and they're not really good at like these single step problems, and that's where photonics are better. So I'm rushing through everything, but yeah. Final products for that. So I'll talk about my process in the actual presentation, but I gotta go for lunch in a minute. So here's my final product. In CAD I modeled like a transistor photonic chip. Here's where the laser goes through, and then it processes the information, and then convert this optical modulator and converts it back to electricity, and displays information. Now I've had some findings. I'm going to convert this into a brochure that I'll be printing out soon. But it's basically pros and cons of photonics, and so it's kind of like an advertisement for photonics. And this is where I would ask questions, but there's no audience. Thank you.